Now we're back. We're back with Newton's second law. We talked a little bit about his first law of inertia. Now we're talking about his second law. Force equals a mass times an acceleration. Let's bring this back here. Did you know that your weight was a force? Yes, weight is mass times gravity. So if you, for example, weigh 180 pounds here on the Earth, and you want to take a trip to the moon where the gravity is 1/6 of the gravity on Earth, well, and you weigh 30 pounds. Of course, your mass would still be the same. So the force, mass times acceleration, is useful in understanding what things weigh. Of course, I've got some pumpkins here. And by the way, when you throw up a mass in a gravitational field, it moves in a parabolic trajectory. In fact, before I do the juggling of pumpkins, I'd like to show you a fun experiment you can do with some pennies. You take a penny, put it on a little streamer here, just tape it on the end, and you can see the parabolic trajectory as it goes through the air. Here's one with a longer streamer, and as you see, it moves in a parabolic trajectory. I'm going to juggle these pumpkins. Some people think I can't juggle the pumpkins, but I hopefully will be able to do it today and show people, oh, yes, I can. So when you juggle, the objects don't go around in a circle. They move in parabolas. So there you go. Oh my goodness, that's a tough one. And, thank you very much. And we'll see you in the next segment. Hi, we're back again. We were talking a little bit about gravitational acceleration. It was Isaac Newton who understood how gravity worked, but he didn't know what made it exist. It was Albert Einstein who came upon the concept as to why gravity exists. For example, Newton was supposedly sitting under an apple tree. An apple fell out of the tree and clunked him on the head. I wonder what Newton would have said when that apple clunked him on the head. Well, I've got my friend Skelly. Skelly, would you like to be part of this demonstration? Sure, Dr. Bones, let's try it out. So Skelly's under the tree. Here comes the apple. Clunk, hits him on the head. I wonder what Newton would have said. What do you think, Skelly? Would he have said gravity? No, he would have said ouch, ouch, ooh. Okay, so he probably would have said ouch. I certainly would have said ouch. Now let's do a little bit of a demonstration about what Albert Einstein was considering what made gravity exist. Well, let's take a look. Here we've got some fabric. It's stretched across a little plate. It's a stretchy black fabric. We can imagine this is like space, very much flat, very much the blackness of space. Well, what would happen if a large mass came upon the flatness of space? For example, the sun. The sun might be something we could consider. Well, we put the sun on this stretchy black fabric, and by and large, it curves the space downward. So when we say the Earth is orbiting the sun, the fact is it's orbiting in this curvature of space. So here we've got our blue planet, the Earth, orbiting the sun. Here I'm adding a little bit of energy because the friction is interacting with the blue ball. But here you see the orbits are due to the curvature of space. In fact, we call it space-time because this is very much dynamic. Everything changes as time changes. All right? So the things change with respect to time. So there you see, it was Isaac Newton who understood the laws of gravity, but it was Albert Einstein who understood why gravity exists. So there you go. Kind of a neat thing you can try. So I'll see you in the next segment.